All right, here are solutions for perfect problem 2 for Math 111. Given this equation, asked to solve it, but do it a few different ways. Do it by factoring, completing the square, and then finally use the quadratic equation. So, okay, this is given in kind of a strange form here with the linear term on the left and the quadratic and the constant terms over here on the right. So we're going to want to rearrange this equation, and actually, depending on what method we'll use, we'll rearrange it a little bit differently. So let's start by factoring. When you're factoring, it only helps to factor if the equation is set equal to 0. So what I mean by that is I want to get all my terms on one side of an equation. I could subtract 5x from both sides, but then my leading coefficient, the coefficient on the x squared term, would be negative, which generally I like it to be positive. It just makes things a little bit easier. So I'm instead going to move everything left. So if you add 4x squared from to both sides of the equation, and then subtract 6 from both sides of the equation, you get to here. And then you factor. You want to rewrite this sum as a product. There's a couple different ways you can do this. Most people learn kind of a guess and check method where you just kind of play with this until you figure out the right answer. There's a much longer method that I'm going to show you, which you should consider as optional. I'm only showing it to you in case you want to use this method. The longer method is this 3-step process. Step 1 says find two numbers, and you want them to add to 5, 5 being the coefficient on the linear term. You want to multiply it at negative 24. Where's the negative 24 come from? It's the product of the leading coefficient and the constant term. 4 times negative 6 is negative 24. So find two numbers that do this. I don't know, it helps to kind of first focus on the multiplication. To get to 24, I could do 1 times 24, 2 times 12, 3 times 8, 4 times 6. But I want negative 24, so one of those two numbers has to be negative and one of them has to be positive. And if you kind of go through that list in your head and start adding them together, you'll find that the only ones that add to 5 are when you get positive 8 and negative 3. Add those up, you get 5. Multiply those, you get 24. Step 1 is finding these two numbers. Step 2, you want to replace your linear term, so in this case 5x, with kind of using the answer you found from step 1. Sure. So replace 5x with 8x minus 3x. So take this original equation here that was 4x squared plus 5x minus 6, and instead write 4x squared plus 8x minus 3x, and then minus 6 equals 0. You might have trouble with that. You're like, well, why? I mean, it's not factored. You just changed it from having 3 terms to 4 terms. That's true. But there's an advantage to having 4 terms. If an equation like this will factor, then when you write it with these specific 4 terms, it'll always work to factor by grouping. The way you factor by grouping is you group your terms. So the first 2 terms I'll think of as my first group, that 4x squared and 8x. And my next group will be this negative 3x minus 6. And what I want to do is factor out something from factor out the greatest common factor from the first 2 terms. So these both have a 4 in common, but they also have an x. So I could pull out a 4x, and then from here I'd be left with an x, and from here I'd be left with a 2. If you have trouble with seeing what's left, you can check your answer easily. You can take the 4x and distribute it back in, and you'll get 4x squared plus 8x. And then you look at your second group here, and your goal is to factor out something so that you'll be left with x plus 2. That something in this case would be a negative 3. Make sure it's a negative 3, otherwise you won't be left with positive x plus 2. And so what you now have are 2 terms. Here's one of them, and here's the other one. And the thing's separated by this minus sign right here. And each of those terms have an x plus 2 in them. So you can factor, again, you can factor out that x plus 2. If you pulled out this x plus 2 and this x plus 2, they're not there anymore, and all that you have left behind is 4x minus 3. It's a long method for factoring. Honestly, I don't use this, but I find that students use it when the leading coefficient is not a 1. If the leading coefficient is a 1, there's a much easier way to do it. If you're really good at kind of this guess and check method, you can sort of just take this right here and jump straight down to here. But I don't know, guessing and checking and the pressure of a quiz, some people don't like doing it. Anyways, we're not done. We factored the left-hand side, but we haven't solved the equation. To solve it, we're going to take advantage of the fact that we factored. We factored so that we'd have something times something equaling 0. It's important that it's 0 because 0 has the special property The only way you can multiply together two things and get 0 is if the first one equals 0 or the second one equals 0. So what I've done is I've changed this one quadratic equation into two linear equations. Linear equations are a lot easier to solve. Just isolate the x. Oops, 4x equals 3. So for this side, just subtract 2 from both sides. For this side, first add 3 to both sides, then divide by 4. And you get two answers. X equals 3/4 and x equals -2. Those are the answers. But what we're now going to do is find those answers a couple more ways. We're going to find those answers by completing the square. When you complete the square, you don't want to start with it in this form. You want to instead start with it in this form. You want your quadratic term and your linear term on one side of the equation and your constant term on the other side. So add 6 to both sides of this equation. And our method for completing the square will only work when your leading coefficient is a 1. It's not, it's a 4. But we could fix that. You could divide both sides of the equation by 4 and get x squared plus 5/4 x equals 6 divided by 4, which is 3/2. I now have things in the right form to complete the square. There's some number that I can add to both sides of the equation that will leave me with a perfect square on the left-hand side here. It's hard to see what that number is, but what's nice is this number will always take the same form. It'll be always half of this number squared. So half of 5/4 is 5/8, and 5/8 squared is 5/8 times 5/8, which is 25/64. So sort of the magic number, the thing that was missing to make this a perfect square, is 25/64. And why you want to add 25/64 to both sides of the equation is because now you have a perfect square over here. You're like, do I? I don't really see this. Well, it's hard to see the perfect square when you got a lot of fractions going on. However, this perfect square will always take the same form, which is kind of nice. It'll always be x plus half of this number. Half of 5/4, as we said earlier, is 5/8 squared. This is the same as this. Try it. Expand this all out. FOIL this out. You'll get this right here. On the other side of the equation, I want to add up fractions. I need a common denominator. 64 is the least common denominator. So let's see, to make this a 64, I'd have to multiply by 32. Multiply the top and the bottom by 32. You'll get 96/64 plus 25/64. 96 plus 25 is 121/64. And what I now have is an equation I can solve. I only wrote the letter x one time, so I can isolate it. It's kind of hidden in these parentheses, but that's okay. Just get rid of the squared first. Take the square root of both sides of the equation. Remember that when you take the square root of both sides of the equation, you got to put in a plus or minus. The square root of 121/64 is 11/8, because the square root of 121/64 is the same as the square root of 121 divided by the square root of 64. And the square root of 121 is 11, because 11 squared equals 124. And the square root of 64 is 8, because 8 squared equals 64. It's not entirely true. I mean, -8 squared also equals 64. But when we're talking about square roots, we take the principal root, whatever. I'm getting into stuff you don't need to know about. Square root of 64 is 8. We almost have the x all by itself. If you subtract 5/8 from both sides of the equation, you will have isolated the x. So we'll get our solutions. It's saying the solutions, there's two of them. -5 plus, -5/8 plus 11/8, or -5/8 minus 11/8. Well, let's see what those look like. -5/8 plus 11/8. -5 plus 11 is 6. And 6/8 is the same as 3/4. -5/8 minus 11/8. -5 minus 11 is -16. And -16/8 reduces to -2. And sure enough, it's the same answers as we got over there. Awesome. One more way. Whew. The last way is using this thing called the quadratic equation. This is a quadratic equation. The quadratic equation is kind of a formula you use to solve any quadratic equation. Quadratic equation. To use the quadratic equation, you got to know what it is. Kind of a memorization thing. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. What is this thing? This is the solution to this equation. If you start out with this equation right here, you can solve it for x. It's really hard to do algebraically, but you can do it. Actually, the key step will be completing the square. You'll do it kind of like we did in red here, except instead of dividing by 4, you're going to divide by a, for example. At any rate, if you took the time to solve that all out and get x all by itself, this is what you'd get, this mess right here. Most people don't even realize where this comes from or don't care where this comes from, but that's where it comes from. And so what it says is that if you want to find the solutions to this equation, all you got to do is recognize, maybe I should write it here, that right here I have it written in that ax squared plus bx plus c form. Just playing the role of a is a 4, playing the role of b is a 5, and the role of c is a negative 6. So all I got to do is copy this thing right here. I already have my x isolated. Just instead of writing negative b, I write negative 5. And then I got b squared minus 4ac. C is negative. Shoot, I guess I have to rewrite that. All divided by 2 times a. Running a little short on room here, but hopefully I can squeeze it in. Okay, so I got negative 5 plus or minus the square root of something. Yeah. Okay, 5 squared is 25. I'm subtracting here, but I'm subtracting a negative number because a positive times a negative is negative. So subtracting a negative is the same as adding. What I'm saying is I'm going to get 25 and add to that whatever the heck this mess is. Let's see, 6 times 4 is 24. Times 4 is almost 100. It's 96. And 96 and 25, as we saw earlier, is 121. Shall I get to here? Negative 5 plus or minus the square root of 121 over 8 is what x is equal to. But because the square root of 121 is just 11, I get this, negative 5 plus or minus the square root of 11 over 8. And as I solve down here, you solve this. Negative 5 plus 11 is 6. 6 divided by 8 is 3/4. Negative 5 minus 11 is negative 16. Negative 16 divided by 8 is negative 2. Throw a check in there because it's the same answer that I got here and the same answer I got down here. And that's all I was going for, so I'll stop this video here.